But the good news is Cardano did exactly what it was supposed to do. When a stall occurs, basically the system recovers, it self-heals. So the nodes go back up, and you'll notice, you know, everything's great, and it's back. And that's exactly what we designed the nodes to do. It's not very satisfying because ideally, every time a distributed system has a blip like this or a stall like this, you'd like to know an exact cause. But the problem is that distributed systems sometimes create what are called emergent bugs. So locally, it's not reproducible, but a collection of things create a collective global state that for some reason triggers something, and the system basically stops for some people. So as I said, there's a team working on it. They're looking at it and they're chipping away at it. And we'll do a post-mortem inside the Git issues. And obviously, if there's a bug in either a Haskell library or a bug in the implementation of the balance R, which was put in for optimizing Cardano, then it'll get patched. But the problem is bugs do require understanding of what triggered them, and that's the thing we're looking for right now. And it's going to take a little bit of time for us to get there. Some cases you can't actually figure these ones out, and they come up once every 5 years, once every 6 years, and you just say, okay, the network recovered, we move on. But sometimes you can, but you never want to drive yourself nuts over it. In any distributed system, whether it be the Googleplex or Microsoft Azure or Amazon Web Services, so these massive large-scale systems, stuff crashes all the time. Systems go down all the time for a variety of reasons. It could be hardware failures or software failures, hacking attempts, cosmic rays, all kinds of stuff. There's even a famous cosmic ray issue with Google Bigtable. And that's okay, because the second thing you do when you build a large-scale distributed system is you build it for resilience and self-healing. So when these types of things happen, the system recovers, which is exactly what occurred here. It was really cool to see how the SPOs came together and how quickly they were on top of this, and they're still looking. In fact, it's a race condition. Everybody seems to be looking for it. And I'm really proud of Smog and Andrew Westberg and all the others that just showed up literally moments after this occurred, in the middle of the damn night, and started collecting large amounts of information and trying to debug the issue. So it just shows you how decentralized and resilient Cardano has become. And we could probably spend weeks or months, perhaps even years, chasing it down for something that may only come up every 5 years, and its impact is it'll stall the network a little bit. This particular issue will never come up again, likely in this format, especially if it's an emergent transient error, and because things are a moving target. When optimizations come in, it may actually recover that part of the code. When Genesis comes in, there's a different operating model. When network upgrades come in, there's a different operating model. Obviously, input endorsers are going to completely change everything. So that's the other part of debugging, is that as you'd like to find something, you may actually just change the code that had the problem and begin with while you upgrade the module to a different state, and not even know that you fixed the particular bug that the issue is caused with.